Good morning, everyone.
Hello, Professor. Is there supposed to be a module 9 or a lab 9? Oh, never mind. I see.
No, that was that week that we that I canceled one. So sorry about that. I got my little nephew and niece staying with me, and you're probably going to hear some noises in the background. Their mama got sick last night, so I apologize for all the craziness you might hear. It's going to involve a dog, a cat, 2 kids, a grandmother, all sorts of good stuff. Anyways, but no, there was 1 week that's missing, and it's because that week I gave you off. We are now in week 11, which I just made available a few minutes ago. So go ahead and y'all can look at that. I actually hid part of it because it's the part from your lab manual. We're not using that at all for this lab. We're just using what's called the PHET 2020, and that's what you'll see that's on there. Anybody have any questions before we get started? Remember, your lab's supposed to be turned in right at the beginning of class, so by now, in other words. Hopefully y'all didn't forget that. Remember, if you don't, by the time I get over there, I'm going to put in minus 50 basically, or leave it at 50 if you already got 50 for attendance. If you don't have 50 for attendance, you'll leave it at 0. So make sure y'all turn that in before I get over to the grade book. Today we're doing projectile motion, and normally in the lab we actually had a device that was spring loaded, and we'd cock it with a gun with a little stick, and we push a little yellow ball into it, and you had like 3 locations you could cock it to, and we always did to the middle. And what we do is sort of shoot it horizontally a bunch of times and then get an estimate of what its muzzle velocity is. And then once we did that, we would then predict where it would land for given angles. So we could actually take, and now that we know the muzzle velocity, we could set the angle of incline to 5 degrees, 10 degrees, 15 degrees, stuff like that. And it would actually shoot and land somewhere. We had a carbon paper down, and the carbon paper would leave a black smudge on the paper wherever the ball landed. We do 5 trials of each angle, take the average of it, and then plot it. And then, of course, we could compare that to what the actual projectile motion analysis does. So we try to make a lab just like that for this lab, only using PHET instead of the equipment. The beauty of the PHET is that's a computer simulation that's built in with the laws of physics already in, and there's no variation due to the springs not consistently have the right strength per unit compression or stuff like that. You don't have air resistances affecting things. You don't have the ball spinning one time more than the other time, all that little stuff. So you only need 1 trial on all these. That's the main thing to point out for that. So before I get you started, let me show you what the lab looks like for today. So I'm going to share my screen, and then I'm going to show you how we go about doing it. So you guys might want to actually take the time, open up that 2020 document, download it first, and then open it. So you download that 2020 document in week 11, open it up and look at it while I explain things to you. You might want to go ahead and open up Excel as well, and be prepared to take some screenshots, because I know what's going to happen is I'm taking the time to explain all this, and y'all are going to like, and it seems perfectly understandable. Then about 20 minutes later, you're going to come back and ask me. so this might save you a little trouble. Here you go. Hold on a second. So the lab, I believe, yeah, this is the one. Okay. So this is the lab we're doing today. Excuse me. So this is the lab we're doing today. It's projectile motion with PHET. Again, that's some software that was made by various grad students and things like that at University of Colorado Boulder, I believe. Anyways, but it's really good simulation software. This one actually has a setup where you have a tower you can crank a cannon up on, and then you can put the cannon on it, and you can fire a pumpkin or a cannonball, stuff like that. We're starting off with just a pumpkin. And you can adjust the height just by lifting this thing up and down. You can adjust the angle by lifting this thing up and down. and it's going to tell you specifically what to do. So for instance, it'll tell you, make sure it's set to 10 meters right here. It's going to get you to record the distance in the data table. But actually you're not going to record that yet. You can record it in this table, just don't record it in your spreadsheet yet. That's perfectly fine. And leave the speed at initial 15 meters per second, but click and drag the target until it is 14.3 meters away. So this little target right here, you're going to move it till it's 14.3 meters. Okay. And then you're going to adjust the pumpkin, adjust the speed until the pumpkin lands very close to the center of the target. Okay. That is going to allow you, once you know the 14.3, that's going to allow you to determine the muzzle velocity, which you'll also be setting by adjusting this little bar, but still it'll be able to confirm it. Record the distance from the point directly below the center of the unfired pumpkin to the center of the target. This is your X value in the previous setup that you set to 14.3. In a real laboratory experiment, you would record several and so on and so forth. Now adjust the angle to 5 degrees, do another one, 10 degrees, another one. You can see we're just going to basically fill out this table right here. Okay. Now all that data you can take, that's fine. But the main thing is don't put it in your spreadsheet yet. Okay. Because when you get to the spreadsheet part, it gives you this 1.20 and 1.40. That's input data that they've given you for which these are the right answers. Okay. If your program, if your Excel spreadsheet, when you write it, if it doesn't have this as this answer and these as the other answers, then your spreadsheet has an error. That's the whole purpose of this, giving you all this numbers. So let me kill this for a second. I'm going to share a different screen. So here's the Excel spreadsheet that I've been making. So you can see I got it sort of made up like the Excel spreadsheet that's in the lab manual. I got the 1.2 and the 1.4 there, and I looked on the actual document. Get ready to sneeze. Hold on. I looked on the actual document, and it said A3 is X over the square root of 2Y over A. So there's my X, there's my Y. So I just typed in here equals, notice A2, that's the X, divided by square root of 2 times, I put them in a different order, A1, which is my Y. And then notice I'm using A as positive 9.8. So that's what I actually typed in. That's exactly the same thing that they're telling you for A3 on the top of, what is it, the second page? Yeah, it's the top of the second page in the lab. It's got in bold print, A3 colon V0X equals V muzzle equals X square root 2Y over A. And notice in this table, in the table that they gave you, the muzzle velocity was 2.83. And that's what I've got here. If I just put enter, you can see it's 2.82, but it's not the same number of sig figs. If I do this and do format cells and make it number to 2 decimal places, then it'll give me exactly what they saw. Okay. Now I'm going to go back to the, I'm not going to show it to you. I'm going to let you guys go back and look at your document again, the Word document that's the lab write-up. And it says B6 is V0Y, and that's equal to the negative of the muzzle velocity times the sine of theta. Okay. So the negative of the muzzle velocity times the sine of theta. So that's B6. Excuse me. That is B6. So I go over here to B6 and I'll say equals negative of the muzzle velocity, which is this, times sine. And now I've got to, I'm going to want to put degrees in here. Okay. So sine actually expects that to be in radians. So I'm going to type 3.14159 divided by 180. And then times, let's just say right here, I'm going to call this the angle. Okay. So I'll put a 0 in here just for the heck of it. So now you see that's 3.14159 over 180. That's basically converting my degrees to radians, and that should give me, of course, that. Of course, that 0 there, which is just like the table showed in equation, I mean, in the table on the actual Word document. Now in C6, I think that's next, C6, it says Vy squared is equal to V0y squared plus 2ay. So we're going to put Vy squared. So this is equal to Vy, which is this one, squared, plus, now they say also in B6, I'm supposed to say V0y squared plus 2ay. So I'm going to say plus 2 times 9.8 times, and now my y value is going to be right here. And I think I got to take the square root of all that. Let's double check, see what the number comes out to be. Okay, so the initial Vy was that. So final velocity in the y direction is computed following relationship, column C. So notice that's
I think
actually, go ahead.
I think if on the formula, I think you forgot to raise it to the power of 2, the x value, I think it was.
Oh, this one? Oh no.
No.
The B6 was, I forgot to add to it as well. So you're somewhat right. Yeah, I did that, but I didn't put the plus symbol between them.
Okay.
And yeah, it's weird because I did sort of a double whammy. I used that 2 for both the exponent as well as for the 2ay. So yeah, that was all jacked up. Thank you for that. And I think
Yeah, no problem.
it wants the final y velocity. Well, they just gave me C6 was y velocity squared. So I'm gonna put square root in front of that. That looks like that might be a typo in the manual. So I'll do this. And of course, right now we're looking at, the final velocity. And this should be the same number that we have in the Word document. And lo and behold, the Word document said 4.849. I got 4.849 again at 3 sig figs roughly. So that looks pretty good. Then for the time, that's supposed to be D6. According to this, D6 is supposed to be derived from, since they want T, you want T is equal to Vy minus V0y over A. So T should be equal to Vy, which is this one. This is the initial velocity. So it should be, whoa, wait a second here. The initial velocity. Okay, so it should be the final velocity minus the initial velocity over A. So what I want to do is I want to do the final velocity minus the initial velocity. I'm going to put parentheses around that. And then I'm going to say divided by positive 9.8. Now, this is a weird system because they're actually forcing the y component of velocity, even though we're shooting it upward, they're forcing that to be a negative direction. That's why I had to put that negative sign in C6. So this should be D6. And of course, I'm going to check the table again. The table said D6 was 0.495. I got 0.495 again, so that's good. And then finally, they're going to give us E6. So the following relationship will give the range, which is how far it's going to go. So the range is supposed to be the muzzle velocity times the cosine theta times T. So what I'm going to do here is I'm going to do equals the muzzle velocity, which is this quantity up here, times, times cosine. And again, I'm going to have to put 3.14159. Well, 3.14159 divided by 180. And then I'm going to say times the angle.
You put 158, sir.
Okay, thank you. Oh, it's not very smart today. 3.14159. I don't even know if I need that many sig figs or whatever. Okay, so that's supposed to be my angle. I just put that up there because I'm not exactly, I didn't check to where the angles are going to be put in this. But either way, you can tie that back to your correct angle. Okay, that gives me 2.82. Oh, I forgot to multiply by time. So I'm going to say times. Now I got to multiply it by the time, which is the column right next to it. And boom, I get 1.4. So notice that 1.4 matches exactly the x at 0, which again, according to the table, that's what it's supposed to be. That's where the angle in degrees go. I'm not very smart. Duh. I wrote angle degrees here. And then I'm like, I don't know where angles go. Okay, so let me go ahead and fix that real quick. So I put angle at C1, so that wasn't in there, but it was when here. Notice this negative. That's where I was telling you the initial velocity going in the up direction is actually a negative. So instead of C1, I'm going to go ahead and put this angle, and that should fix that. There's no angle in there. There's no angle in there, but this one there is. So instead of C1, I need to change that back to there. Okay. Now I get that. Now I got 5, 10, 15. And what I'm going to do is copy these formulas down and see if it matches those lines that they gave me in the table. If it does, then I know I'm right. And they seem to have only given me 2. Or no, they might give me 3. It's hard to tell. Now I'm going to copy this formula down. And it looks to me like I'm supposed to get, for the angle of 5, I'm supposed to get negative. Something's wrong.
Yeah, it's I'm seeing it right now. So your A3 value isn't the constant value. It's changing as you pull the spreadsheet down.
Gotcha. But the A, yeah, that's right. Because so I need my dollar symbol on this.
Yeah.
So that A3, let's see where I call it at. I don't call it there. I do call it there, but I do need to tie it down to $. Good job. And $. Again. And A6, I actually do want to advance, so that should work okay with that one. So let me copy these down and see if I get to 0.247 and to 0.491. Yep, it looks like I do, so that looks better. Let's see if I call the A1 on this one too. Yes, I do call the A1 on this one, but again, that one should be $A, $1. Now let's make sure I get the 4.856 and 4.875. Yep, I got that. And does the time call on A1? It does not. So the time should be right already. And if I look at what the book has, the time is 0.521, 0.548, 0.521, 0.548. That works. And in X, I did call for A3, which is okay. I also called for A6. Oh no, yeah, A3. That's always got to be A3. So I need to do $A, $3. And I always need to call to A1, but there's no A1 in this one. There is a D6. That's okay. So this should be right now. So now I should pull this down and I should get the same values the book had, which is 1.467 and 1.525, 1.47 and 1.53. Yes. Okay. So that's what you're going to go through in the very beginning part of this, is just make sure you have your spreadsheet set up properly so it will do all this. I'm going to set all these rows. I'm going to format all this data to be 3 sig fig or 2 decimal places. So I'm going to say format cells, and you can even do 3 decimal places if you want. That's what I'll do there. Okay, so now I can look at it and see if it's reasonable compared to what I have. Now that I have all that, now I can go ahead and stick in my actual data, which is going to be the 14.3, or excuse me, the 10.0 for the Y, the 14.3 for the X, and then 0, 5, 10, 15, 20, all those angles. Does everybody understand that?
Yes, sir.
Okay.
Do we need to fill in all that on the table in the example spreadsheet in the thing or in the book?
No, just basically, as long as you've done that, then you know the thing's working properly. So when you actually do it for the appropriate numbers, that's the data table I want to see.
Okay.
So I want a photo of that in your actual document. And I think it gets you to make a graph. You should make a graph either way and put that in there as well. Okay. All right. Looks like we got 13 people, 12 people today. So I'm going to make
And
up my break.
above where it says X data, what does it mean? Y equals blank.
In the lab manual, which part are you talking about? Yeah, that under number 8.
Mhm.
Yeah, Y equals 8. Remember they said they're going to make you set that tower to where the cannon centers at 10.0 meters. That's what goes there.
Okay.
Yep. And at 0 degrees, you're going to set that to 14.3 basically for the 0 degrees. Does that make sense? All right. Well, yeah, I noticed yesterday students had a real hard time getting that, and I explained them and how that had to be used, but I didn't actually show them. So hopefully this will be better for you guys. I'm going to set up the breakout rooms and let you choose again, like I always do. Of course, once a group gets down to 2, I'm going to throw them in another group, and also as you go into these breakout rooms on your own choosing, I'm going to announce what your first name is and what group you're going into, just so if anybody else knows their partners but don't know what room they're in, that'll still work out.
I have a question.
Yes, good for it.
Can I talk to you before you put out the break rooms after you get them done?
Yeah. After everybody goes in.
Yeah.
No problem. Okay, so I'm going to set up 4 break rooms. I'm going to let the participants choose, and it's now been created. Let me announce how everybody goes in there. Who was that asked me the question? Was it Christian or Reese?
Yeah, it's me,
It's
Tristan.
Christian. Okay, so Christian will be the last one that stays out. I'll come and answer any questions once y'all go into your room if you still have a question, and let's just let me and Christian have that. I'm going to stop recording now.